So, in our previous class, I have just introduced the electrostatics of conductors. Just introduced how charge sharing takes place and how to find fields, how charge distribution gets affected. All these things I have discussed very clearly, and I hope you have followed. Those who are absent on that day, hope you have followed right. Anyone who did not gone through that video, raise your hands. Okay, fine. Rest all right. Now, in today's class, we will continue the topic. Please try to understand. In last classes, we have come to know potential, and we know something about potential energy, which means if we have 2-point charges, if we have 2-point charges like this, we have 2-point charges like this, separated by a distance a. Besides, they are having charges Q1 and Q2. The interaction energy. This is nothing but potential energy. Can be given as a that is called interreaction energy. Now try to please understand. There is another thing called self-formation energy. There is another thing called self-formation energy. What exactly is this self-formation energy? Let us take an example. A charged spherical shell. Now imagine you have a charged spherical shell. Say, for example, you have a uniform distribution of charge. I am assuming that the radius of this is r. Let at an instant its a charge be q. So what is going to be the potential of this? 1 by 4 pi epsilon naught q by r. That's the potential on the surface of shell. Potential on the surface of shell. Now, to transfer further dq charge from infinite onto the surface. From infinite onto the surface. Right. You are transferring. Work done by external agency. I am doing slowly again. Work done by external agency is dW. So clearly, by definition, what is dW? V into dq. Is nothing but 1 by 4 pi epsilon naught q dq by r. The total work done starting from an element zero, negligible amount of charge. Initially, the sphere is with negligible amount of shell, negligible amount of charge. Finally, I made it till Q. The process of charging started from a level 0 to a level Q. So this is what we require. And this one will become 1 by 4 pi epsilon naught q square by 2r or simply kq square by 2r. You can notice that. Right. Kq square by 2r. So whatever that the work done by you, work done by external agency plus work done by conservative force is 0. Because you are all the time carrying slowly. So kq square by 2r plus minus of u final minus u initial is equal to 0. You already know, in an uncharged stage, we will call that potential energy reference as 0. So therefore, potential energy finally is kq square by 2r. And this is what we will call as self-formation energy. That is called self-formation energy, which is different from inter-reaction energy. Right? Any doubt? Remember, this I have derived it for a charged spherical shell. Anyone having doubts on this, you can please ask right now. Right. Now, following with this, self-formation energy of a spherical volume distribution. So we will speak of strictly about spherical distributions only in this. Don't question me, what if it is like a cylinder? What? See, there is a complex cases. Basically, they are complex. That is the reason why we won't discuss those things. We will discuss strictly as per our syllabus. It is only spherical distributions. Now, imagine you have, see, This is charge, in fact. And the relative permeability of the material is 1. Not possible, I know. But right now, for our convenience, we will say that is 1. So you require some material space within that spherical portion. When I said space, it may have some dielectric properties. For our convenience, right now we are defining that as the dielectric constant is 1. Because some other day we will deal dielectric chapter. In that chapter, I will discuss completely about the properties. But right now, our approach is very simple. Any doubt till this point? Now the question is how to find. For this purpose, I will imagine you imagine an elemental shell here. Okay. See how this volume distribution forms. Like imagine it like an onion. So what is the final shape of an onion? This elemental, minute, small sphere over which a shell, over which another shell, over which another shell. Likewise, you will have the structure. All shells are constant. Now imagine the construction happened till this point whose radius is r. Now on that you are adding this shaded part. Now let us define rho as uniform volume charge density. Rho is defined as uniform volume charge density. So what is the charge that is contained in that elemental shell? It is nothing but 4 pi 3 pi r cube rho. What is the potential in that? K cube by r, which is nothing but K into 4 by 3 pi r square rho. Yes. Yes. Earlier, it is a shell is the shaded part. The shaded part is enclosing this much charge. Right. Now the question is, now what is the portion of the charge in this shaded part? This dq is rho times 4 pi r square dr. So what is the work done in this process? This is nothing but V dq K into 4 pi 3 pi r square rho dq rho into 4 pi r square dr. So it is like K into 4 by 3 pi rho square. I am having a very good intention writing it like this. I know that I have done some mistake here. I should show that 3 r power 4. That is how I am doing work. Gradually increasing the size of this distribution. dW refers to the elemental bulk. Right. And by repeatedly doing that, I am constructing this from 0 to capital R. R is equal to 0 to a level of R is equal to small r is equal to capital R. Now, by the way, one needs to know that 4 by 3 pi r cube rho is cube. So 4 by 3 pi rho can be written as q by r cube, where q is the total charge enclosed in the volume distribution. So therefore, this further can be expressed as q square by r power 6 3 times r power 4 dr is dw. So unit total work done by external agency is 0 to capital R. Kq square by 3kq square by r power 6 r power 4 dr. So you will get this as 3k by 5 q square by r. Because numerator you will get r power 5, denominator 5, r power 6 is already exists in the denominator. So overall, you have this. Till this point, any doubt? Remember, from this I can say work done by external agency plus work done by conservative force is zero. So therefore, potential energy is 3kq square by 5r. And remember, whether it is a positive charge or negative charge, finally it is a positive. They are repulsive only. Doing work against a repulsor. Whether it is a negative charge, you are applying negative charge in that case. If it is a positive charge, you are carrying positive charge from infrared in that space. Okay? So these are two very famous relations, and you need to remember because it's not possible every time that you derive all these things. Not possible, literally. So you should remember. So this stands as self-formation energy. There is a famous relation, a famous question related to this in Iridium that I will open right now. Books. It's a very good question actually. This is the question actually. Okay, fine. It's not available straight away. I'll draw the content. Imagine I'm creating a very small space. It's a very, 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 very small space. This is a conductor. So actually, I should write this as a conducting section. Inner radius A, outer radius B. This is the center. At this point, I have plus B charge. This is the initial configuration. Find the minimum work required to transfer point charge okay from O to infinite through the narrow gap. Imagine just because that I am creating a gap, it won't affect, the gap will not affect the distribution, the uniform distribution of the charge inside as well as outside this particular shell. Now, what is happening over here? What is happening here? We have a plus charge here, basically. So this affects a uniform negative charge inside and a uniform positive charge outside. Again, I am telling you that the narrow passage do not affect the uniform distribution patterns of the charge. And don't ask me any question related to that. Can someone please help me? What is the total energy initially? What is, in what forms that you are seeing the total energy initially? Yes. How many interreactions are there? Interreaction energy 1, interreaction energy 2. What are the interreactions? This is one interreaction. This is another interreaction, and outer one with the inner one. Interreaction energy 3. Followed by self formation energy 1, self formation energy 2. Any doubts? Any doubts? There are 3 interreaction energies and 2 self formation energies. Why? Clear? You can see that. What is the first interreaction energy? Means the negative one interreaction are very simple. Due to the negative distribution, anywhere inside the potential is minus kq by A is the potential into the charge at O plus Outer charge distribution is again small q only. Remember, there is only one charge, that is that the charge placed at O. Because of its presence, you can see two inductions, a negative charge on the inner side and a positive charge on the external surface of this particular ship. Done. Now the twist factor is IE3. IE3. What is IE3? Minus KQ square by T. ಏನನ ఎవరిని రియాక్ట్ కాకూడదు. Why? Okay. Due to the outer shell potential, only due to the net contributions gets cancelled. Whatever you said is right. Is you happy now? Are you sure? Are you happy now? Next, self formation energy. KQ square by 2A. KQ square by 2B. Any doubts, boys and girls? IE3 means no. You are not following here. That's a problem. IE1, IE2, IE3 is external distribution with the internal distribution. Right. Now, what is again the net distribution finally? This is U initial. It represents the entire pattern. Okay. When Q is at infinite, nothing. Point reaction at 0. So work done by external agency plus work done by conservative force is 0 because you are moving it slowly. So now what is happening? Work done by external agency plus minus U final minus U initial is equal to 0. So work done by external agency is minus UI, which is plus KQ square by 2 times that's the result. Any doubts? Sure. Can you ask me the question again? If Q is still interreacting with cells, how come you said that is infinite? What is the meaning of infinite? Then when you yourself is saying that there is no interreaction, how come you account all that? The moment you take out the charge from the center, Nothing is left inside. What is the charge? Net charge on the shell? Zero. Whatever you are seeing, this red colored minus sign and a blue colored plus sign are due to induction. The point charge inducing charge on inner as well as outer. Clear? Boys, do you have any doubt? Do you have any doubt? This is what we will call as self-formation energy and fundamentals related to that. Okay. Anyway, since we have done some discussion on this, again, I'll do some brush up part. What happens when a conductor is placed in an uniform electric field? Now, imagine this is a region of uniform electric field. Now you have a conductor. Conductor. What is the effect? Because that you are placing this in that, what is the effect? Ideally, but that's not the picture actually. I'll show you the picture originally later. Let this be some E naught. You will notice E naught here as well as E naught. What happens inside? That you tell. You know, inside a conductor, E net must be zero. You know this. How is it possible? See, how is this possible? I can see one field outside. It has to be cancelled. How is it possible? No, actually, because that you are placing this conductor in a uniform field, what is happening is these free electrons are there in the conductor. They are pulled opposite to the direction of the field. And now what is happening is here you can see that here. So on the surface, not inside, on the surface, you will see they are mobile or free charges appear. Now, due to this free charges, we will have an E in due to this. So what is E net? E naught minus E in. It is supposed to be 0. So therefore, E in is nothing but magnitude. Direction wise opposite. So if you apply Gauss law, it takes some small portion here, a very small portion here. You imagine a Gaussian portion here. So minus E naught ds is 1 by epsilon naught times minus sigma ds. So therefore, sigma will be epsilon naught because you know this is negative charge. Okay, minus sigma is magnitude. Sigma refers to magnitude. Plus q minus q, q represents the numerical value. Minus 5 coulomb. 5 is a numerical value. Okay, na? Are we clear? Got the point? Right. There is another, no, just give me clarity once again. Have you understood this approach or not? Just give me some clarity. Right. One more a different thing that I would like to discuss with you is that 1 minute. NCRT, there is a very good content. Right. So there are some important terms related to the electrostatics of conductor. Here completely I am dealing NCERT terms, which it is very much needed when you are actually preparing for the actual mains. That is the reason I borrowed diagrams from NCERT. Yes. What are those important terms that I will write one after the other? First thing, inside a conductor, electrostatic field is zero. Already I have proved that in the previous case. Here I have proved that. Right. Next. So the redistribution of charge takes place so as to ensure that this takes place. And one more important point, you can notice that the potential V is constant. So it acts like a equipotential volume. Wherever the material is available, there the potential is constant. Next. All the charge resides, all the charges resides on the outer surface of a conductor. And remember, this is the case irrespective cavity with charge or cavity without charge. There is a cavity with charge, the net charge in the cavity is zero. Right. One more important point, at the surface of a charged conductor, electric field must be normal to the surface at every point. Suppose if you want to violate this, say for example, you want to violate this. What is that you are informing me? It is not normal. Okay. What is that you are informing me? There is a normal component and a tangential component. What is that you are informing me? In the conductor, there is an electric field. Across the surface, there is a tangential component, which is not possible. Why? If there exists E, there exists dV by dx, which is not possible in case of a conductor. Right. And one more important point is the interior of a conductor. The interior of a conductor cannot have excess charge. You cannot make a charge to stay inside the conductor. Again, I am telling it's not inside the cavity, within the conductor. Even you give, it comes onto the surface. Right. Next. So you can see here, what is this? Electric field almost on the surface. It depends on sigma. It depends on sigma. Okay. So there is a property called this comes under electrostatic shielding. If, for example, I placed this conductor so even though you placed this conductor in an external field here, you can see there is an external field, undoubtedly, non-uniform field. This is the case where conductor in a non-uniform field. Can you please tell me what difference that you have noticed if a conductor is placed in a non-uniform field? Sigma is different at different points. You can see that. Whatever it is, what is the net field inside? You can see that E is 0 inside. In a cavity, field is 0 inside. So this principle is what we will call as electrostatic shielding. This is electrostatic shielding. Very important practically in our life. So why practically it is very important? Simple. In fact, it protects us from being electrocuted. Suppose you are in a car, there is a thundering storm outside. Don't come outside. Stay in the car itself. The only care that you need to take care is don't touch any knob-like kind of thing. Any knob with a metal connection that connects inside to outside. If you avoid that, you are safe. Otherwise, you will be electrocuted. That's all. So even in NCRT itself, there is one example question which we need to see. We need to see that. One example question, important example question. This is one important example. You need to remember because in mains you may have this. That is the reason why I'm just copying this. These are actually very important cases. A comb run through one's dry hair attracts small bits of paper. So why? Simple. Dry hair. I think last 1 month, last 40 days, you would have noticed in your own house, you will see sparks when you are drawing blankets. Yes or no? Dry. So because of that friction process, the charging takes place. While you are combing, same thing will happen. Gets charged. And this charged comb, when placed nearby the, what do you call, small bits of paper, it induces charge on the paper. Because of the induction process, those induced charge are pulled towards the core. That's the reason. Similarly, ordinary rubber is an insulator, but special rubber tires of aircraft are made slightly conducting. Why is it necessary? Remember, in the process of friction, the tires gets accumulation of charge, keeps on accumulation of charge. If it is very sensitive particle, sensitive instruments around the uh, around the aeroplane suddenly gets discharged, they could damage some signal transmitting units and all that. So to make it a discharge, that metal portion is embedded in the tires. Even petrol carrying tires, you'll write inflammable, something like that. Petrol carrying tires also, they will carry some chains close by the tires. So why they will carry those chains close by the tires? When, because of the accumulation of the charge during the transportation, that gets regularly transferred to the earth by means of those metal chains. Because during the process of journey, friction between the air and the surface of the container, it gets charged. To discharge, you require these metal chains to be hanging. So all these things they have mentioned here. NCRT point of view, you might expect such questions in future. But to avoid that, I'm posting all these stuff to you right now. NCRT point of view, what's all required, that I have pasted here. Please notice. So for these chapters, just follow the notes. So you don't even require to follow NCRT books thereafter. Any doubts? Just introduced. Now, coming back to the point, I just have some arrangement. No, I'm just still dealing very fundamentals. Very fundamentals. Right. See, what happens when a neutral conducting sphere is placed close to a point charge. This is the first question. Second question. Find the magnitude of electric field due to the induced charges just below the surface at a point defined by R comma Q. This is a conducting sphere. Now I have point charge Q. placed at a distance r. There is some point P which makes an angle theta. So what happens when I place a point charge over here? Can someone please tell me first of all that point? This point charge will induce charges there. And again, that is a non-uniform charge distribution. Sigma is high nearby this point, almost tends to zero as you move away radially. To conserve this, this is how the charge is induced. This is how the charge is induced. Remember, the induced charge here is definitely less than, because all the flux that starts at Q is not ending on this field. Remember, a portion of that is ending over. Right. And that is the answer to the first question. The answer to the second part of the question is just inside near P. E net is equal to C. Why? Because this is a conductor. Who are contributing to E net? E due to point charge plus E due to induced charges. You see. Therefore, the magnitude of the induced charge, electric field of the induced charges is the same as the magnitude of the field due to the point charge. Do I know how to find the field at P due to this with this given data? Yeah, I know. This is nothing but KQ by R dash square. R dash can be obtained from cosine rule. So KQ by R square plus small r square cos. Any doubts? Any doubts on this? Boys and girls? వారం రోజులు ఇంట్లో నిద్రపోయినా చాలా నీకు దొన్నపోతలా నిద్రపోతు నిద్రపోవడానికి వెనక్కిపోయి కూర్చున్నాం. సిగ్గని మించట్లా? సాటర్డే వచ్చావా? అదే నీకొక్కడికే ఉన్నాయి ఊళ్ళు, వీళ్ళకి ఎవరికీ లేదు. సిగ్గనిపించట్లా? ఎలా నిద్రపోవాలనిపిస్తుంది? ఒరే, నేను ఎంతసేపటి తర్వాత వాడిని డిస్టర్బ్ చేశారా? మీ ఇద్దరు డిస్టర్బ్ చేశారా లేదా? వాడికి ఎదిగారా లేదా? విజయకి వాడిని 2-3 సార్లు అబ్జర్వ్ చేశాకే కదా నేను కలిపి వాడిని కదపమని చెప్పింది. బోర్డు ఎక్కడుంటే నువ్వు ఎక్కడికి వస్తావు? It's a very, 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 very important observation. I might use this in the course of a future whenever it is necessary. Right. Right.
Induced magnitude equal to E for magnitude and repel. తర్వాత మీరు R తీసుకుని R డాష్ తీసుకుని
అదంటే P అనే పాయింట్ దగ్గర ఫీల్డ్ R డాష్ మీద డిపెండ్ అవుతుందిగా. వాట్ ఈస్ ద ఎక్స్ప్రెషన్ ఫర్ ఫీల్డ్ డ్యూ టు ఏ పాయింట్ చార్జ్? KQ by R square. అదే నేను రాశాను.
Magnitude of E induced equal to magnitude due to EQ.
EQ. I can find the magnitude due to EQ. Remember, just inside near P is 0, not outside. Right. So one of the important points, one more important point that I need to write is the entire, because I might use these points later on. Entire volume of a conductor is equipotential. Right.
Cavity లోపల పెట్టినాం అనుకోండి సార్. లోపల మనం ఒక పాయింట్ చార్జ్ ట్యూబ్ పెడితే నెట్ ఫ్లక్స్ వచ్చే 0.
అవును, అవుతుంది,
ఎందుకంటే ఎలక్ట్రిక్ ఫీల్డ్
అవుతుంది. దెన్ నువ్వు ఏం అడుగుతావు? నువ్వు ఆన్సర్ చెప్తున్నావా, స్టేట్మెంట్ ఇస్తున్నావా, డౌట్ అడుగుతున్నావు? ఇంకా నేను క్యావిటీస్ దాకా పోలా, జనరల్ ప్రాపర్టీస్ మీద డిస్కస్ చేస్తాను. నాట్ డిస్కసింగ్ అబౌట్ క్యావిటీస్. రిమెంబర్, ఫర్ ఎగ్జాంపుల్, ఇంకా ఐ నీడ్ టు డిస్కస్ ఎ లాట్. నియర్ అది కూడా డిస్కస్ చేశాను. ఎలక్ట్రోస్టాటిక్ ప్రెషర్ కూడా డిస్కస్ చేశాను అంత ముందుకే. There is a theorem which is rarely available in books. Rarely. I'm very confident NCERT it is not there. Even SU Hermite is not there. Even Galaxy also it is not there. Very rarely we will use. That I will discuss. Okay. So while I'm introducing such things, I need to be a bit very careful. I should make sure that myself I'm giving you from zero on. So today's class also it is ABC only. It started higher end model because I know people like those people will sleep. They didn't follow those classes earlier. You would have heard as if like news channel because I will question you. విన్నారా వినలేదా అని అడుగుతా. విన్నానని చెప్పడానికి విన్నారు అంతే, బుర్రకి ఎక్కించుకోవాలా. మరి నువ్వు కూడా రాలేదుగా మొన్న, ఏమైంది? వాళ్ళందరికీ ఊర్లో ఉన్నాయి. దిక్కుమాలిన సుశాను, దిక్కుమాలిన బాను, మీకే ఊళ్ళు లేవు. వీళ్ళందరికీ ఊళ్ళు ఉన్నాయి, నీకు నాకు ఏమీ లేవు ఊళ్ళు. మనకి హైదరాబాద్ తప్ప ఇంకేమీ దిక్కులేదు. మన సందు చివరు కూడా ఎవరికి తెలియదు మనకి. అందుకే మనం సాటర్డే వచ్చేసాం. వీళ్ళందరూ ఊళ్ళో వెళ్ళాలి. ఇప్పుడు మన హేమంత్ చెల్లెలు ఉంది, సదినా చదవ పైన ఇంకో రోజు ఎట్లా కావాల్సింది. ఆ ముందర అమ్మాయి కూడా సహస్రాక్షి, నువ్వు కూడా రాలేదు సాటర్డే. ఏ ఊరేగా? ఏమైంది మైరోగం? హెల్త్ బాగాలా? నువ్వు కూడా రాలే, ఎందుకు రాలే? That is why I am avoiding the recording. Uniqueness theorem. We don't need to learn under some label. No one will question you what is uniqueness theorem. Or no one will question you identify uniqueness theorem statement out of the following. When I am applying somewhere, you should identify that shall theorem alawat chesaru. Likewise this. See, it starts like this. For a given total charge, for a given charge distribution, otherwise, okay, on a conductor. There is a book called Griffiths. And there is another book, I said, Berkeley Course of Physics. These are the two books that are considered with the utmost standards. In that, they have given uniqueness theory. కాబట్టి ఇది రానంత మాత్రం ఇష్యూ ఏమీ లేదు. చాలా మంది చెప్తారు ఈ పేరు పెట్టి చెప్తారు. నేను 2 years కింద చెప్పేవాడిని. తర్వాత కొంచెం చెప్తే మంచిదేమని అనిపించి ఐఎమ్ జస్ట్ డిస్కసింగ్. రైట్. For a given total charge on a conductor and దీనిలో ఆర్డర్ వేరు, మళ్ళీ దీనిలో ఆర్డర్ స్టార్ట్ చేస్తుంది. అంటే ఆ ఇయర్ అలా స్టార్ట్ చేస్తే ఐ ఫెల్ట్ కంఫర్టబుల్ గా ఫీల్ అయినట్టు నాకు అనిపించింది. ఆర్డర్ మార్చుకున్నాను. For a given total charge on a conductor and a charge configuration of the universe. There are two terms that I have uttered here, don't get confused. For a given total charge on a conductor and a charge configuration of the universe, the charge configuration of the conductor for which field in the conductor becomes zero will be unique. Only one such arrangement is possible. Unique means that. అరే కొత్త మాట ఏం చెప్పాను నేను. నువ్వు ఎలా ఛార్జ్ ఇచ్చినా ఒకే పద్ధతిలో అది డిస్ట్రిబ్యూట్ అవుతుంది, ఒకలాగానే డిస్ట్రిబ్యూట్ అవుతుంది. నీ కండక్టర్ అయినా సరే, యూనివర్స్ అయినా సరే. ఈ మాట ఓ పెద్ద యూనిక్నెస్ థీరం అని నేను చెప్పనక్కర్లా. ఓ పాయింట్ లో రాసేయచ్చు. ఇక్కడ రాసిన పాయింట్స్ లో వన్ ఆఫ్ ద పాయింట్ గా రాసేయచ్చు. రాయకుండా జస్ట్ ఒక తరంలా చెప్తాను. So for a given total charge on a conductor and a charge configuration of universe, the charge configuration of the conductor for which field in the conductor becomes zero will be unique. You cannot assume n number of different distribution. Only one such distribution is possible. Okay, right. Now we will discuss about some arrangement. It is a configuration. Okay, arrangement. Okay, America configuration. Yes, conductor మీద చార్జ్ ఉంటుంది. దాని బేసిస్ మీద నేను ఇప్పుడు కొంత డెప్త్ లోకి వెళ్తాను. ఫర్ ఎగ్జాంపుల్, so this is a conductor. Isolated spherical conductor with charge plus Q. Undoubtedly, there exists only one way uniform charge distribution such that sigma into R is a constant. Yes, R is a constant, sigma is a constant throughout. Can you please suggest to me any other distribution so as to make the conductor in such a way that the E inside is 0? Suggest me any other given charge to this conductor. The only way that the charge distributes on that is to satisfy the condition sigma into R is constant. No, sir, you are cheating us. This is another conductor. Spherical conductor with charge plus Q, comma, near a point charge. Now, can I question you one thing? Will the charge on this conductor be uniform? Why? You disturbed the configuration. Remember, even though the charge on the conductor is still Q, but the previous configuration and the present configuration is different. Since you disturb the configuration, the charge now on the sphere gets distributed in a different way from the previous. And again, this is unique. So long the configuration is fixed. For example, now what is happening here? This is how it gets distributed. Maybe here this is minus Q dash. Okay, here it is Q plus Q. Now, what is the potential at O? The potential at O is due to induced charges, due to charge Q, and due to small q. And this is kq by 0, kq by capital R, small q by small. Why induced charges are 0? How much is the negative charge? The same magnitude of positive charge will exist. And the net effect of that is 0 at the center. The net effect of that is 0 at the center. Now, if I choose some other point P, which is at a distance R dash, remember Vp is the same as Vo, because same 2 points inside the conductor. So therefore, V induced charges plus Vq plus V small q is V. V induced charges plus Vq plus kq by R dash is kq by R plus kq by small r. With this, you can find the value of these two contributions. Any doubts? Not only that, you can even find the field of these contributions also. Why? You know how to find the potential due to small q as well as field due to small q. So the remaining part you can find. Why? Because net is 0 inside. Net is 0 inside. That is the meaning of that uniqueness theme. Okay. What if? So I have just shared two different situations. That is a cavity part. Right. So you can see this is a cavity part. The entire rest of the portion is conductor. I have placed a charge Q over here, point charge. Now this will induce a negative charge. In this case, there is no point charge outside. Okay. Outside charge distribution uniform. Inside cavity, charge distribution is uniform if it is a spherical cavity and the Q placed at center of a cavity. Remember, in such situations, one point you need to remember. Q plus this combination. The combination contributes zero potential and zero electric field at any point okay, outside the cavity. For example, you take a point here. What is the potential at this point? It is due to the outer distribution only. At this point, don't even know that there exists some small q and minus q charge. That point, don't even know that such a thing exists. Okay? So I'm just dealing basics only today. Very basics. Right. Now what if same arrangement that's a cavity of irregular shape. Now you place the small q charge like this. Irrespective the shape of the cavity, still the charge outside is even now, in this case also, together they contribute zero potential, zero, irrespective of the shape. Which means, again, if you imagine a point here, at that point, potential is only due to the distribution of the charge on the surface. That point, don't even know that there exists a cavity and a internal charge distribution. So I have given certain points. Remember, the basic problem here is applying one after the other. In spite that I have taught all these things, again, n number of times students will ask me, sir, teach this. We are having confusion. Why you will have confusion? You will fail to follow the order. You will fail to follow the order. So you will face the problem. Else there is no issues. Now I just have a doubt. So till this point, any doubt? The distribution of the charge inside the cavity happens in such a way that the center of mass, the center of that negative charge exactly coincides with the location of the existence of the positive charge. So together they contribute nothing outside the system. Got the point? Sure? Right. So each observation is a different thing. Don't combine. There are different observations. Right. Think just stop here because a topic depth is so high, you require following and all that.